All right. So, hello everyone. I am indeed Jaakko Peltonen from Tampere University. I am a professor of statistics and data analysis there. The university has recently merged. It's formed out of the previous University of Tampere and Tampere University of Technology. So we have a new logo and a new name, which is nearly the same as the previous University of Tampere, but slightly different word order. This is the new us. And these are the people that I've been working with to make the papers that I'm going to be talking about today. Jyrki Nummemaa and Kalari Järvelin are professors that I collaborate with. Hishbul is a postdoc and Ziuan is a doctoral student that I have been supervising. Thanks to them for their contributions. So today's talk will be about exploring online discussion with probabilistic models. I thought I'd get a little bit more technical, but feel free to doze out in the places where you see an equation, although I will try to skip as much of those as I can. Some of you asked for papers related to the previous talk. Well, these are the papers related to the current talk, published in a couple of recent conferences. So, why should I talk about this subject and why should you listen to it? Well, discussion, online discussion is a huge resource telling us about what is going on in society today, what people's opinions are about various topics, what their interests are, what their interests are as consumers, as creators of media, and in various other roles. So it makes sense that we would like to find out what's going on. And the thing is that this online discussion often occurs in venues that have a hierarchical organization. They're not just unorganized, for example, collections of tweets sent from various places. They can occur in that way, but they can also occur in these hierarchically organized venues. For example, Suomi24 is a prominent Finnish conversation forum, one of the largest, perhaps the largest, I don't know the current statistics. Online discussion also occurs in the form of comments on products, for example, reviews, and those also occur in hierarchically organized websites like Amazon, for example, which has a very large and deep product hierarchy. Now, those hierarchies are created by the people who own those websites. They manage them for their own business purposes. They create sections that they hope are useful for capturing people's attention, for keeping them online, for keeping them visiting that site. But they are simplified divisions. They are not really something that would come from a guaranteed knowledge of what people are really interested about. It's just the guess of the administrators. So they typically don't really suffice to describe the variety of interests that people have, because, well, people are complicated. They have a lot of things that they are interested about, and they combine those interests also in very many different ways. So in that situation, we can't just trust what the administrators have created as an organization of potential interests. We also want to take a look ourselves based on what we actually see in the discussion. So extracting from the discussion what the potential interests of people are and how those interests relate to these sections that arise in the forums, how they relate to, for example, authors, how they relate to other covariates, time, for example, and other things like this, is a very crucial need if you want to monitor and track online discussion. Now, I mentioned Suomi24. Let me mention a few more facts about that, since we are going to use that as one of the use cases. Suomi24 is indeed one of Finland's most popular message forums, and it has been around for quite a while. There are 18 years of conversations that we have in our database, 2001 to 2018. Well, of course, now 2019 is also ongoing, so it's growing and growing. It has thousands, well, over 2,000 of these conversation sections in a hierarchical organization. There are millions of threads. There are, to my knowledge, 60 million usernames. That's actually quite a lot, considering that that's more than the population of Finland. So that might mean, for example, that people use different usernames in different situations. It's mostly available in Finnish, but there are also content in other languages. There are, for example, sections that are in Swedish, and there are a large number of visitors every week. This is an old statistic from 2015 when they had nearly 1 million visitors a week. And you can see, do I have a laser pointer here? Is this? Yes. So you can see here an example of a conversation thread. It's discussing the type of overalls. You've got your usual beginning post, and you have a number of replies, replying either to the beginning post or to each other. And of course, you have other things shown there, adverts, various types of relatively simple links. And here on the left, you can see just a few of the many conversation sections that are available in there. Okay, so often these message boards are really organized hierarchically as sections, subsections, their child sections, and so on. This is not the only possibility, of course. There are also some kinds of message boards that use a flat organization where you just have basically a root and a bunch of sections under that. Reddit, for example, is mostly organized like that. And some specialized message board, like, for example, some car enthusiast message boards might also be organized like that. But when you get to thousands of message boards, that becomes a little bit unwieldy. I would argue that Reddit also is a little bit unwieldy. It's hard to know what kinds of message boards there are in there. So hierarchical organization is very prominent when you get to big discussion venues, especially when you have a large range of interest, when you have basically a general interest message forum. So then those sections form a tree, typically. And as I already mentioned, those trees of sections, they're created by administrators, and they don't really describe the actual variety. So we want to not just trust them, but also compare what we can find from the data itself. Now, who would benefit from something like this? Who would benefit from analyzing a discussion? Who would benefit from comparing that analysis to the organization of the hierarchy? Well, for example, administrators of those forums, they can benefit because their interest lies in keeping users engaged with the forums, making sure that they come back and see adverts again and again, and that's partly how they make their money. Analysts, for various purposes, who want to track what kind of interests are going on for many other purposes, for, well, profiling, for example, voters, or profiling consumers, or many other kinds of things. Tracking social trends for other kinds of purposes. Anyone who is interested in that sense what is going on could benefit from analysis like this. So in particular, for the administrators of forums like these, if you have a hierarchy that is poorly designed, that doesn't support the underlying interests of the people who are actually using those forums, then, well, they could learn from the analysis and they could modify the organization, add some links where they are beneficial, and so on. So what happens if the organization differs from the actual interests? How can they differ? Well, some of the differences include that you may have threads, conversation threads in different sections that are actually talking about the same kind of content. Or you may have one section that actually contains many types of different content. You may also have, within each conversation thread, multiple users commenting, and they have different interests. And those threads and the sections may, over time, change from what their original interest was. They may digress or drift from their initial interest towards something else. Users who use these forums may not be available, they may not be aware of everything that is possible in those venues. They may not be aware of all the places for the discussion, and therefore the place where they choose to discuss something may not be the optimal choice. So this is also something that can cause a difference between what is planned and what is the reality. And of course, there may be situations where you have a topic of discussion that just doesn't fit any existing section or is partly fitting many sections, so people may end up discussing the same thing in several places. So there are many reasons why where people discuss their interests is a complicated question. So we try to simplify. So one way to simplify is to just forget a lot of the details and just treat the contents of a conversation thread as just a bag of words from which you can notice some things very nicely. You can notice that, okay, this seems to be a prominent word, no surprise considering it's the topic, but you can also notice some other things like man, use or where and so on are prominent words. So you can have a word cloud like this, and that's fine if you're looking at an individual thread. The problem is individual threads are not what people are interested in. When you have multiple threads, each one of them would become a word cloud. So it's not even a single cloud, it's basically a sky full of clouds if you want to talk about the contents of an entire discussion venue. So this becomes quite hard to manage. No one has time to read through all of these word clouds. Because remember, you have millions of these threads. So we need to simplify further. How can we do that? Well, that's where computational tools come in, and I'm going to be using a lot of food metaphors here because it's, well, I guess just after lunch for somebody, for others it's just before you are going to go to lunch. Whichever you choose, I hope I'm going to whet your appetite. So imagine that you have bowls of candy. How would you describe the contents of these bowls? Would you really say that, okay, this left bowl contains one red candy and another red candy and one purple candy and another purple candy and one yellow candy and so on and so on? Most likely not. It would be kind of tedious, boring, and not really the most efficient way. So what about if you knew that, okay, you had actually bought a number of candy bags from the store? Then you might be able to say in a simpler way that, okay, this first bowl was mixed half from Assamix and half from Tutti Frutti. And maybe the second bowl was 1/3 from two types of Tutti Frutti and one from Remix. So to most people, this would be a completely sufficient description. It tells what is going to be in the bowls. You don't need further details. So this sounds like a nice type of simplification. So what about if you just saw the bowls and you knew that they had been mixed from these bags of candy? Could you tell which bags they had been mixed from? Maybe, if you knew enough about the bags. If they were your favorite type of candy, you might recognize, okay, clearly I see some of these Assamix candies in here, maybe. Maybe I see some Tutti Frutti candies in here, and so on. An even harder question is, what happens if you don't know the bags, but you still know that they have been mixed from some bags? Can you then guess both how they have been mixed and what they have been mixed from? This sounds complicated, but it turns out that it's possible. And of course, really, we are not talking about candy. We're talking about word clouds. And we want to find out how these word clouds may have been mixed from underlying topics of interest to people. This is called topic modeling. And we have been working with a number of different types of topic models, where this is really the question. When you see the word clouds, can you find the underlying topics? So they are models that represent documents as bags of words, and they generate, or they tell a story where the documents have been generated as a process, where you first choose what you want to talk about, and then you choose some words based on what you want to talk about. That doesn't sound like a bad idea. That sounds quite reasonable. That first you think what you want to talk about, then you choose what to say. And the reverse, what I had in the previous slide, is you want to guess what people wanted to say, what they wanted to talk about based on the words that you have seen in the data. That's called fitting the model. There are many types of topic models available nowadays. The famous one is called latent Dirichlet allocation, LDA. There is also a non-parametric version called a Dirichlet process or hierarchical Dirichlet process. Non-parametric here means that you don't have to know how many bags of candy were used to mix the bowls. You also learn how many bags of candy were needed. This is another way to describe the same process. So you assume that every document comes from some mix of topics. A document could be, for example, a conversation thread in an online forum. Every topic in turn would have its own mix of prominent words that describe the topic. So then the content inside a document like a conversation thread would be done by repeating a process where you pick a word so that you first choose which of the topics of the document you are going to talk about this time. And then once you have picked that, then you pick a word from the words in that topic. This is the mathematics, but as I said, if you're not interested in that, feel free to ignore. Now, the next thing is that I mentioned these hierarchical organizations of these venues. So here are the actual 2,434 sections of Suomi24, organized as a nice visual representation here. Here is an example, a very small part of the Amazon.com product hierarchy. So if we know that the conversation arises in a hierarchy like this, we should take those hierarchies also into account when we try to extract these topics of interest from the word clouds. So how can we create topic models that are appropriate for hierarchical venues like this? That's not easy. We also want to later on take author information into account. And we don't just want to imagine that a section defined by a forum administrator defines the topic. That may not be true. Just because a section is called, let's say, cars, doesn't mean that someone in that section wouldn't start talking about politics, for example. They may have good reason to do so. Maybe, for example, they want to talk about fuel economy or something like that, which relates to politics in an abstract way. So we extend these non-parametric topic models, these hierarchical Dirichlet processes. They are not easy to extend because we want especially to really model these kinds of hierarchies, like the Amazon case here, where you have a number of products, and then each product has reviews which may talk about different topics. Topics could be things like safety, price, durability, ease of use. Many kinds of things like this could be interests of users. And each of those topics could arise in any document, and those documents in turn, those reviews of products, could arise over any of those categories. So not just in the very lowest level leaf nodes of the hierarchy, but anywhere. One of the models we developed was called THDP, Three Structured Hierarchical Dirichlet Process, which turned out to work well. Those models are usually written out instead of only relying on mathematical notation. We usually couple them with graphical representations. This is the basic hierarchical Dirichlet process, where these are some variables that overall control what kinds of topics are present over a whole bunch of documents. This would represent what kinds of topics would be active in a particular document, and this would represent the step of creating the individual words in the document. This, instead, is what we want to do. So here we have individual documents but they arise under sections. Those sections arise under parent sections. Those arise under grandparent sections, and so on, all the way up until a root of a hierarchy. So we basically want to model how the interests percolate down from an overall very broad set of interests to more narrowly and narrowly defined sections of a conversation venue. We don't say that a particular topic has to be active in one of the branches downward. We don't, for example, say that a section called cars has to talk only about cars. We just say that more likely the further down sections are going to be more specialized. This is an example of that for a particular hierarchy. Now, I mentioned that you would want to fit these kinds of models to data. That is also described typically using food metaphors, specifically Chinese food-related metaphors, and we do the same. So for the hierarchical Dirichlet process, the metaphor is called a Chinese restaurant process. The idea is that the words that are available in documents are treated as customers for a Chinese restaurant. They come to the restaurant, they sit at a table which is offering various types of dishes, which are actually topics here. And they tend to choose dishes or tables which are popular with previous customers. So this represents the process of generating a new word into a document so that the word arrives in a restaurant. It looks that, okay, maybe this table looks very, very popular, so I'll try that. I'll go there and take the dish from there. That means it chooses a particular topic of interest, and then the actual vocabulary word is picked from that topic. This way, words can either pick one of the existing tables, or they can always sit at a new table, growing the number of topics as much as needed. When you have a flat hierarchy, there is an extension of the hierarchical Dirichlet process called the hierarchical Dirichlet process, which is the Chinese restaurant franchise. So now you don't just have one restaurant, you have a whole franchise of them. And that is basically the franchise are the overall interests across the whole document collection, whereas the individual restaurants tell the interest in a particular document. But we wanted to go even further, right? We wanted to have this big hierarchical thing. So what are we going to call it? Well, we are going to call ours an imperial Chinese banquet. There is some precedent for that. There was an imperial feast documented even in Wikipedia, which is apparently one of the grandest meals in Chinese cuisine. So this means that we have not just a few restaurants under a franchise, but we have restaurants under parent restaurants, which are under grandparent restaurants, and so on. So the individual words, again, come to tables, but the dishes that are in those tables are brought there by waiters from an upper level of the hierarchy, which in turn get those from further upper levels, and so on, until finally, somewhere far at the top, there are cooks at the kitchen that actually prepare those dishes. Now, it's a lot of flowery metaphors, but actually it does result in an algorithm. The algorithm is one where you basically first try putting the words sort of randomly across a bunch of tables, and then for each of the words you try to pick it out of its current table, and you try to see that is there some other dish for you that you would like better, something that would be better suited for you, more likely to be an appropriate topic for this particular word. You repeat this a whole lot of times, and ultimately you end up with a set of topics that match the actual content in your hierarchical document collection. We tried this out on Suomi24 and on Amazon. Basically, the idea is that you could try to do two kinds of tests here. We are trying to compare content of documents to the places where those documents occur in a hierarchy. So you could try that, okay, I tell you the place in the hierarchy, can you guess the content? Or you could try the other way around. If I tell you the content, can you guess the place in the hierarchy, right? So you could try to predict one given the other, and that way you can tell whether the model you have created is good. So I'm going to just briefly do that. So we tried this, and first of all, what are these topics like that we extract from documents like this? Well, they're basically lists of popular words. This is Amazon fishing accessories. This is a dataset related to reviews of various fishing accessories. So all the topics in this particular data are going to be words related to fishing accessories. And they make a lot of sense, actually. For example, look at this. This is a word, these are words related to scales, reviews of scales. Scale, weighing things, accurateness, measuring things, digits, tapes, pounds, batteries, all things that are related to operating scales. There are other topics like this which are also described by reasonable words. So basically an expert looking at these resulting word lists can fairly easily tell what this topic is going to be about. And of course later you can go back to the documents, see which documents had this topic as very active, and then you can actually read those example prominent documents. So there are a lot of ways like this that you can monitor what these topics seem to be about. And that's, of course, much easier than trying to exhaustively go through millions of documents. So topics are sensible, and we also tried these prediction things that I mentioned. Before I go into that, I meant this hierarchy really results in inheritance of topics. This is an example where ice spearing equipment inherits some of the topics, like number 6 here, that were present in the parent section, ice fishing accessories, but it drops some of the other topics that would be available in the more general parent section, but are not anymore available in the more specialized child section. So the logic sort of works out in the way that you would expect. The child sections are more and more specialized. These are basically just a bunch of result numbers that say that we performed nicely. I think no one really cares about the specific numbers, so these first graphs here are basically measures of how well we can predict the content of documents given that we know where they are going to occur. And we tried that for a bunch of Amazon hierarchy subsets. This is fishing accessories, this is politics, this is Suomi 24 politics. This is, I think, Suomi 24 health and relationships. And these measures here are called perplexity. It's the amount of surprise, basically. The smaller the perplexity, the less you are surprised by what you saw as the content of the document. So smaller is better here. And we are in general better than this comparison HDP model. The other prediction task was predicting where the document should have come from when you see the content of it. Here it's the other way around. Bigger numbers are better, and again, we do better than the comparison method would have. Skip that. So this is a hierarchical model for online discussion. It works nicely in the sense that it can predict content better, outperforming some earlier methods, and it is ultimately easy to understand for someone who is familiar with these kinds of topic models from before. A few extensions. One is that, okay, what if you don't just want to take into account the sections, but also the people who wrote the documents, the authors? Seems quite sensible, right? So there's a very easy way to include those. Remember these previous graphical models, the HCP model, for example? Well, Let's again have this kind of hierarchical model, but now this last part here, where we are generating the individual words, that last part is changed just a little bit. Now, this represents a topic of a word, an interest. But now, instead of just generating from that the actual observed vocabulary word, we're also generating which author would have written it. So at the same time, we describe how the words arise, but we also describe how the authors of those words arise. After that, the rest is pretty much similar. Here is again an instantiation of that for a small hierarchy. So you would have this kind of generation of words and their authors in every section of the hierarchy. Skipping that, that's the mathematics of the generative process. And again, the food metaphor, right? So now we wanted something where we would have authors available as part of the dishes. So we went with something called a fine chocolates banquet this time. So imagine that you are like a really fancy chocolate maker and you don't just put the chocolates in the wrappers, you sign the wrappers, right? So people know that it's you who made the chocolate, right? So this is the metaphor here. And again, the idea is that individual parts of a document, like words, they come in, they choose these dishes, which then give particular vocabulary words, but they also give the authors that are likely to come with those dishes. Here is again the hierarchical venue organization of the fine chocolates banquet. So it's the same as the previous picture, but now you simply generate always both the word and its author as part of the dish, which is brought there from higher up sections of the hierarchy. It again results in an algorithm, again similar to what we had before, so no need to bother with the detail. This, in case you do have some interest in the detail, basically, as I said, you operate these algorithms so that you first set every word to some table in these restaurants, and then you try to pick iteratively a better and better table for every word. You remove it, and then you try to find a better table based on where the rest of the words are sitting. Some of the equations are here. So this first equation here is when you have a particular word that you have removed from its current table, this is what tells that, okay, which table should you pick instead? These are probabilities for which table is likely to be a good choice. You can also pick again the connection of a table to a higher part of the hierarchy. So you can choose which dish arrives at a particular table and so on. So these kinds of equations are repeated again and again as part of the optimization. The same kind of evaluations can be done as I showed previously, but with a few differences. Remember, now we have both content of conversation threads, we have authors who participate in the conversation threads, and we have the sections. So we have again a bunch of Amazon product hierarchy subsets and a few subsets from Suomi24. So again, the topics end up shared across different sections, so, and there is inheritance happening. So, for example, a peanut butter related section in Amazon would have particular topics as the most prominent ones. Other topics would be in coffee substitutes. Some of them are shared. For example, number 37 is active both in peanut butter and coffee substitutes. Others are different. For example, coffee substitutes and jams and preserves share another topic. So people who want to track interest across multiple sections, they can track these topics rather than looking at every individual word in a word cloud. Again, the results are meaningful over the different topics. So now, since we have authors, we also know for every topic which authors are most likely to write about this topic. For example, this is for the Amazon food, and there are a few authors who particularly like to write about coffee and how to recommend coffee types and flavors and what kinds of packs are involved, brewers and so on. Other authors are more about, well, for example, how to clean and what kinds of flavors are available, what kinds of cleaning agents are available, and so on. Some are talking about sugars and calories and fibers and so on. So it's very easy to notice relevant content and what the content seems to mean based on these kinds of models. So again, we can measure the amount of surprise for content given that where it occurs and who wrote it. So this basically answers the question that can you believe what this person wrote here? If you can believe it, then your amount of surprise is small and you have basically done well in predicting the content. We do better, again, smaller numbers are better here. We do better than a number of comparable other models. The same occurs across all of these different data sets. The other thing that we could try, well, we could try the section prediction too, but here we wanted to predict that, okay, who is the author, given that you see the content and the section where it occurs. This is quite relevant actually, because a lot of people use pseudonyms, right? Or they may use different usernames for different type of content, even if they don't think of it as a pseudonym, they just don't think that the usernames mean anything. So this allows you to predict that who is the author given the actual content and the place where it is written. Here, larger numbers are better, and we do better again than these comparable other models. The same thing happens across multiple datasets. So this was an extension to take into account authors. Again, it performed nicely. And lastly, I want to talk about something a little bit more exploratory. The last few examples were all about kind of automated modeling, but how do we bring the human in? I mentioned analysts, right? But how do we allow analysts to track what is going on? Well, this is something where I'm sticking with the food metaphor, and I'm talking about something called PIHVI, online forum posting analysis with interactive hierarchical visualization. So if you ask that, where's the meat of this talk? Here is the meat. So, by the way, this name was suggested by our Chinese our Chinese doctoral student, so he didn't know what it meant. It was just a happy accident that this acronym came out of it. So we are going to try to make an interactive system out of this to visualize and explore this hierarchical text corpus of online forum postings. So these topics, or the word clouds even, they seem to be good representations for the content of individual threads, perhaps even individual sections, but not really so that you would need to be able to say, what's the overall picture? How can we give you the overall picture? Well, we are going to try to do that by means of visualization. The topics or the word clouds, they are high dimensional. So we are going to try to reduce the high dimensional clouds to small dimensional, well, pancakes that we can put on a two-dimensional screen for a user. But since we are interested in these hierarchies, we're also going to put some color in there to represent how the hierarchy arises over the different types of content. So, doing this, there's a lot of work that is available for exploring various trends across time or networks of conversation participants. We are skipping that part. We are focusing on the relationship to the hierarchy and other things that explore, for example, temporal variation are easy to incorporate. So you would want to allow a person, an analyst, to track things like what kinds of topics are users discussing and where is the discussion happening. You would also want the user to answer questions such as which trends are individual threads of interest related to. You would also want them to be able to answer the question like what kinds of other similar threads exist for a particular thread that this analyst considered interesting. So these things should be easy for an analyst to find out, and these things should remain easy to find out when the number of these threads, the number of sections and the depth of the hierarchy would all grow to be very large, as it does in things like Suomi 24. Our result looks something like this. Now, it involves a number of linked views, where the first three are always shown, the rest are on demand. So the first view here is a content-based map. This looks like a cloud itself, doesn't it? But it's now a cloud that represents the entire content of Suomi 24. It's an interactive scatter plot of the whole collection of threads created by dimensional reduction from their content, so that the threads are organized by content. Similar threads end up nearby in the cloud. The colors here on the cloud, they represent the sections of Suomi 24, which are again organized, the colors themselves are organized by similarity, so that sections close by in the hierarchy, they will get similar colors. So again, this coloring is created by the dimensional reduction itself. It's zoomable. Unfortunately, I don't have the online demo with me, but this is zoomable so that you can zoom in further and further into this cloud, so that you will see, you will ultimately see individual threads as dots colored by their sections. And at less detailed zooms, the dots will represent thread groups, and the diameter of these circles will grow as the size of the group grows. And the color will be, in those larger groups, the dominating common section. So, for example, if all the dots are under this section here, or its child sections, then the color of this dot will be chosen for this one. Skipping this. There's a simple thumbnail so that you can move around when you are zoomed in and you can still find out where you are. There is this section plot which you can use to select a few sections of interest. And there are sections for exploring the individual content, lists of individual thread names, contents of individual threads. So here's an example of selecting just a few threads of, a few sections of interest. And here you can see where they occur over the different types of content. So for example, you can see here that there seem to be at least two major groups of content, different types of content that are related to this set of sections. They are highlighted here. You can zoom in, as I said, and here is an example of a zoomed in view. So you can find out, for example, for a group of threads, what is that lowest dominating section, which contains most of the underlying threads. Or for an individual thread, you can find the title and the section name of the thread. If you highlight a bunch of threads, you can find out the whole list of titles that there are inside that rectangle, and you can find, of course, the contents of individual threads. In this case, it seems to be about dogs and their hearing-related difficulties. So this supports all kinds of typical good desired properties of interactive systems. You can find an overview, you can zoom in, you can filter, you can get details, you can relate content to other kinds of content. These are typical things that people want in interactive systems, and they are supported in this system as well. There are a bunch of details related to the implementation, some typical natural language processing steps, and then a dimensionality reduction step that takes the representation of each conversation thread either as a word vector or as a vector of topics, and then creates from that a two-dimensional placement onto this map that you just saw. Some mathematical details of that, which I skip. Colors, also mathematical details to how we generated them. Basically, the idea is that we wanted close bisections to have similar colors, but also there are some practical details that we needed to take into account. For example, the branching factor, we needed to take that into account in how we assigned these distances between sections to find basically a good set of colors. It's surprisingly tricky to get it right. Then a little bit about the zooming. So before I mention some examples about what kinds of things you can find out, I just want to mention that we did a few tests also with people where we took SOM24 content, did some pre-processing, and asked people that, okay, using this interface, can you find related content that you wouldn't easily find? Basically, if somebody is interested in a particular type of content, let's say exercise or weight loss, for example, they might find one thread that they have read, and then they see, okay, I am in a particular SOM24 section, maybe it's actually a section related to weight loss, let me check what else is in that same section. That's the naive thing. Everybody can do that. You don't need any special system to do this thing. But can you find content that would be related beyond that? Content that would be related, but not in the same section, right? So we asked people to do tasks like this. So we asked people that, okay, can you find threads about hearing in sections other than cool? Can you find threads about Matti Nykänen in sections other than Nykänen? There is a section for him. Can you find Swedish language threads in Finnish language sections? Can you find threads about hair in other than the Hiukset section? We compared to a baseline system that didn't have this content-based plot, that just had a hierarchical view of the actual hierarchy, but otherwise had similar properties. You could navigate and you could select sections and look up individual thread contents. A number of participants performed this task, and we evaluated the results, and we asked them finally a questionnaire also about their experiences. And of course, we asked which system they preferred. Overall, people seem to like this system. They were able to make discoveries besides having good performance in the tasks that we gave to them. So the system seemed to help them understand the content in the discussion venue. So they found things like, okay, sometimes Swedish is used for trolling in SOM24, not for actually having Swedish language discussion, but for basically belittling somebody else. And for example, this Matti Nykänen was an example where it turned out the system can easily place threads related to Matti Nykänen near each other, even though they are coming from many different places in the SOM24 venue. They were able to find threads from more diverse sections compared to the baseline system. There was a little bit more of a learning curve, but not very steep for this new, more complicated system. We basically evaluated that how much relevant content over time. So what's the amount of relevance, in a sense, over time that people were able to retrieve? That was our measure of comparison for these tasks. And, well, basically, we get a lot more relevant content over time. So it was easy for participants to find a lot of related content using this kind of system compared to a baseline. The questionnaire asked many kinds of questions from the user, such as, would you like to use the system frequently? Do you find it cumbersome? So basically they needed to agree or disagree with statements like this. And everywhere where we had any kind of statistical significant difference, it was in favor of this new PV system. So people wanted to use PV more frequently than the baseline. They found it less cumbersome. They felt more confident using it. They found it easy to find what they were interested in, more easy to find a thread to read. They would use it more than the baseline. They would use it again more than the baseline. And overall, basically they can find what they are interested in easily with a system like this. They would like to use that for exploratory data analysis. It's also easier to use, interestingly, than the baseline and gives the participant more confidence. Even though it's more complicated as a tool, maybe it reassures also the people more that, okay, we have really seen everything. I trust my findings. Same thing graphically here. And everybody preferred the PV system. So this was an interactive system for finding content and exploring content in a large hierarchical text corpus of online forum postings based on a large scatter plot coupled with a coloring that represented the hierarchy. And you can use it really to discover some things that are surprising, more or less. For example, somewhere around here in the system, there is content coming from a red section related to sports and exercise. And it's right next to a green content coming that is representing things like pets and animals. Turns out the common factor was running. Why? Well, the things next to each other were actually things related to running, and next to that were threads related to dogs. If anyone has a very young, vigorous dog, you may know that walking the dog actually gives you a lot of exercise. So maybe that's the common factor. There was another similar example that pets and house furniture, those sections had content that was placed content-wise near each other. What was the common factor? Aquariums. Aquariums are not just a home for the pets, it's also a part of the house decoration. So you can find things that are sometimes very easy to explain, but you can also find more complicated things if you keep looking at exploratory systems like this. So overall, there is a lot of interesting things that can be done and need to be done to properly explore online discussion. You need ways of going beyond looking at individual words or individual word clouds. You need ways of modeling the shared interests that occur across these sections. The topic modeling cases that I showed are an approach to that. You also need a way to bring the human experts into the loop, and exploratory systems like the one here are one approach towards that. And this is certainly not everything that can be done in this area. There's a lot more work that has been done by others, and there's a lot more work that remains to be done. So that concludes my talk. Thank you for your interest.
First of all, what will happen with this pihvi? Are you developing it further, and how accessible it is for overall usage? And secondly, have you used open source software Gephi for visualizing, and what would be pros and cons? Thank you.
Okay, thank you. So pihvi, the system, is something that we have currently just used for internal use, but it is something that we could release as a software package. We are not only studying these text data, we are also operating with a number of other domains. For example, we have an ongoing project related to political discussion with a number of political discussion data sets and so on. So tools like these are applicable also more generally than to the SOAM24 examples that I showed here. And they may become online available at some point. I think that we should progress towards that. We don't have an online release currently, but I think that there is nothing in particular stopping us except, cleaning things up and making it usable by others that are not experts. And as far as the Gephi goes, I'm aware of Gephi, and it's a prominent system, but it's oriented a lot towards things like graphs. And here, the graph alone would not be enough, because the graph, for example, represent the graph of the sections, for example, and that did have a graph layout, which was shown there for the colors, and that you could create with something like Gephi, for example, easily. But then this thing, the content-based map, that's not arising out of any clean graph, really. It's just comparing every possible conversation thread to every other possible conversation thread. So that's not something that Gephi would be directly able to deal with. There are other software tools that can do this dimensionality reduction task once appropriate pre-processing work has been done, and that's what we did also. We applied a dimensionality reduction software that we were familiar with, that we understood, and that was appropriate for this kind of data. And the results of that, well, you can think of them as locations of every thread on this two-dimensional map, and something like that, once it has been created, I suppose that could then be brought into exported. It could be exported and brought into other kinds of tools if someone, for example, was really very familiar with Gephi, for example, or some other visualization system, and they wanted to bring this data in. So it could be done, but it might not be optimal for that purpose. The interactivity, for example, between this graph of the sections and this graph of the content, that's not available in Gephi. So all of this, the coupling together of these two types of data, that's something special here. Okay.
So I found it interesting that you were using a Finnish corpus here with regards to the Suomi 24, because Finnish language is known for its complexity when looking at bags of words. So you did mention that you applied some lemmatization, but what is your view on the state of the art with regard to cleaning up Finnish language to make it usable with topic modeling tools or algorithms rather?
This is a very good question. We used a lemmatization tool that is popular. It's in use at the Language Bank of Finland, and the quality of that is relatively good. There are some cases where it, for example, might mistake what type of word something is, like whether it's a noun or a verb, in some cases where it's unclear. But most of the times we found that it did extract the lemmas relatively well. There is a bunch of pre-processing that has to be done for that to work, of course, things like removing some characters that are not in the character set, and removing words that are not in Finnish at all, but are, for example, some nonsense garbage, or are coming from some other language. Those, of course, cannot be properly lemmatized. But overall, we do not require that every part of the lemmatization has to be perfect, because this is ultimately statistical. We are looking at the overall interests. So one word misunderstood is not going to change the overall sense of what the conversation thread is going to be about. So as long as the errors in lemmatization or other NLP pre-processing are within a tolerable range, I would say that the results are still usable for this kind of topic modeling and interactive analysis. But I do agree that if you want to have something that says very detailed things about individual threads, then you probably shouldn't trust entirely the content that is given by the lemmatizer and other NLP tools. You should also look at the actual raw text as well. But that's very easy to do in systems like these. You can directly go to the original Suomi 24, for example, thread online, because they remain online. You can read them just like any other Suomi 24 reader would look at them.
Thank you. would like to ask that you have here taken the hierarchy as given, of course, naturally, but have you considered on making a proposal of better hierarchy instead of just analyzing the or providing insight of the existing usage?
Right. So there are some topic models that try to take a flat collection of documents and they try to build from them a hierarchy of topics or potentially a hierarchy of the documents. I think just the topics. But I would say that that is not a sufficient approach, because when a hierarchy does exist, you should take that into account. And that's what models like the ones that were shown there are trying to do. However, if you do have successful topic modeling, then after the fact, you can look at how the topics are shared across the hierarchy. And if some topic is, for example, used in several places, or if some combination of topics ends up being used in 2 different places, then you could well be able to suggest that, okay, maybe these 2 sections are sibling sections at the very least. Maybe you could use that to suggest a different hierarchy, or you could suggest a shortcut between them. For example, imagine the let's say the aquarium case. You could suggest that, okay, you seem to be reading about aquariums in the pet care. Have you also considered reading about them in this house furnishings section? Because you might find some related content. So things like the map here could be used directly as that kind of suggestion. The colors that are next to each other are sections or section groups that have to do with each other. So for example, the red and the green seem to have something to do with each other, even though they are far apart in the original hierarchy. That doesn't mean that everything in the red has to do with everything in the green, but just that there are some links. Hierarchies are, of course, nice and easy, and that's why most venues choose hierarchies. But of course, real-life interests are not guaranteed to be a tree-like hierarchy, like something like the aquariums. It may well be that this kind of link should exist at the level of the aquarium discussion, but should not otherwise connect the upper levels of furnishings versus pets, for example. So we might end up suggesting links, but not necessarily suggesting a different hierarchy, just adding some links to what the existing hierarchy already provides.